Well, this one's pretty weird. Let me draw you a picture to kind of help you with something here. Um, let's say we have a piece of pie or pizza, and we say a circle of some sort, whatever. And I'm starting with a half. This is the sum of an infinite geometric series. A series is a sum of a bunch of different things. And if we started drawing a picture, and I said, I'm going to start with a half. Half of this circle is that portion right there. And I'm going to add to it a quarter of a circle. Well, I can do a quarter. I can just take half of what's left, right? And then I can take an eighth, which is half of what's left. And what I'm doing essentially is I'm cutting in half what I have left in each case, cutting in half 16. And as I continue to cut in half and shade in, I'm getting closer and closer and closer to filling this thing in. Will it ever be done? Well, that's kind of a weird question, because if we're cutting infinitely small halves, we're never going to get done. But as we approach infinity, we're basically about to fill in this missing space. So that you can kind of do what it's saying, although sometimes it's going to overlap and you're going to get more than what you have. The honest truth is, a problem like that, it might just be good to try and fake your way through that, something like that. But what you have then is another equation to memorize. I'm sure this is high on everyone's list. The sum of an infinite geometric series. Here's an equation that you can use. A sub 0 means this is the zero term of the sequence, the initial value basically, over 1 minus the common ratio. If it's geometric, that means you're multiplying by something to get the next one. If we start at 1/2, I take 1/2 of half, that's 1/4. I multiply that by 1 over 2. If I multiply that by 1 over 2, I get 1/8. Multiply that by 1 over 2, I get 1 over 16. So the common ratio is 1/2. So to find the sum of an infinite geometric series, where we don't have to draw a picture and say if we keep going forever, this is what it will approach or become, this is an exact value. So I take the 1/2 and I'm dividing it by the common ratio, 1 minus the common ratio, which is also 1/2. This gives me the number 1/2 over 1/2. You can multiply by the reciprocal, or you can just recognize that anything over itself is equal to 1. So the answer is 1, whether it's by a picture or by remembering a new equation that is the sum of an infinite geometric series. Speaking of geometric or arithmetic series, we've got this. What's the nth term of this arithmetic series? Well, we see that there is an increase here of 4. And as we go, we've got an increase of 4 that's common here. If it's arithmetic, then we're looking at the equation. Well, T of n equals m times n plus b. Our old friend y equals mx plus b is the great-grandfather of this sequence here. So it doesn't matter what form you have, as long as you recognize there's a growth, which we'll call the slope for. And then there's the y, or the y-intercept, the initial value, whatever it is. It's not pictured here, by the way. The zero term is the one before. So how do we know what that is? Well, we're adding 4 when we go this way. If I subtract 4 when I go back, I'm back at negative 4, which means our initial value, or our zero term, is negative 1. So T of n, y equals, I forgot I had an x here, doesn't even matter. T of n equals 4n minus 1, so the answer is D.